Hello. Again, my name is Fabian, as I told, and I give you the talk about what is new in NetworKit under the hood. In the upcoming roughly 15 to 20 minutes, I give an overview what happened in the code base and the project management. If you're used to NetworKit, some of it will already likely get your attention. I think other things are more subtle. This morning I got that there are quite some newcomers here, so that's good because I will also cover quite some basics there. So what is this talk exactly about? I'm going to cover 4 parts. Most interesting for newcomers is likely how we distribute NetworKit, so how you can install the tool, when is a new version available, and what can you expect from it. The second topic covers interactive notebook tutorials. I will give you a quick overview over our current state here, and I present an outlook at our plans for the near future. For the experienced users, we will have a look at what changes happened in our build system, in particular how we restructured our siphon code. And in the remaining time, I will talk literally about everything else. So give you examples how we maintain the same code quality in the project and how you can use these tools by yourself. And finally, show you some updates on the documentation of NetworKit. So let's start. Yes, first of all, here's a look at the architecture of NetworKit. So I know this is technically not new since it's designed this way since its first release in 2014. I use this slide here, however, to show some recent addition in the upcoming minutes. So as you can see, just a quick overview, that NetworKit is built in 3 layers. We have an optimized and parallelized C++ core containing all data structures and performance-based algorithms. It uses the utility data structure library TLX as an external reference. On top, we have the Python interface, which lets you easily use the code below via an interpreter. And to connect both layers, we use siphon, which exposes essentially all C++ stuff to Python. 2 layers of NetworKit actually needs to be compiled, so both the siphon and the C++ part. And yeah, this is what is done when you try to install NetworKit via the, let's say, classical way. So since its first version 2014, you could type in pip3 install NetworKit, and then a pre-uploaded file is checked out, including all this code, which is mandatory here. And the build system compiles then both the C++ code and the siphon interface, and this all together is then installed as a Python module, essentially. So in order to use NetworKit, therefore you don't only need pip3 on your system, but also a suitable C++ compiler, the siphon compiler, and Python 3 development headers for your OS. So as I said, this was the traditional way to do it. In addition, we created a NetworKit package, NetworKit packages for popular package managers. So currently we have Brew for macOS and Conda plus Spec as cross-platform tools. We choose here to split the package based on the need of you as from perspective as a user or a developer. So if you, for example, do Conda install NetworKit, it's called the same here, technically only the compiled predefined Python functions and modules are installed. The core beneath is provided by libNetworKit. So this is the C++ part, independent on that libTLX. Both are automatically installed if you install NetworKit. You can also do this only for this both lib packages or install only one of it if you need this explicitly. For example, if you want to link libraries or expand the C++ core only or stuff like that. The advantage here about using this package managers is having, let's say, more flexibility than normal Python environments would have. You don't have to care about the requirements we saw with pip. These are all automatically handled and unit tested separately before release of a new package. So you can create production-ready environments or development-ready environments against different compilers and version of Python with short commands without messing with your normal environment. And I can show it also to you. Prepared something here. So let's take Conda, for example. We can install a simple environment by this command. So we take here NetworKit with the most recent version and the Python 3.6 version. We could also leave this Python equals 3.6 here out, and it would take the most recent one from the system, which would be 3.8. So after some seconds, everything is installed and ready. Let's see. Should be at least. Yeah. So, of course, when I tested it, it was much faster. But nevertheless, so once it's finished, then we can activate our newly created environment, and then we have everything there. So we have the Python there, we have NetworKit there, and then we are essentially finished and can use it right away. Ah, there it is. So I can show it. The only thing I now is have to activate it. And now we are ready. Approve it. So we have this 3.6 Python version, and if I would start Python, I could use NetworKit right away. So back to here. Yeah, if additional package managers or ways of distribution are needed, it would be good to know actually. And yeah, so let us know if there is something more needed here besides the pip, spec, and conda and brew way of install things. Speaking also of installing certain versions of stuff, you can expect a new major version of NetworKit every 6 months now, with having a minor release after 3 months in between. Both minor and major version releases are done with a fixed schedule in mind, and patch releases, of course, on demand. This means, for example, that 8.0 will come out at the end of November 2020. For the difference between a major and a minor release, we follow best practices actually. Major version can, but doesn't need to, include incompatible API changes. Minor releases adds functionality in a backwards compatible manner, and the patch release is done when we want to include bug fixes actually. And this release schedule is effective since 6.0. So besides installing NetworKit, I hope this is readable actually. Besides installing NetworKit and learning to use it in the interpreter directly, another possibility is to use our Jupyter notebooks. We invested quite some time here to recreate typical workflows for common network analysis tasks, and yeah, in parallel give you an overview about all modules NetworKit actually has to offer. So if you first want to take a look without installing or downloading anything, we had also this question earlier in the chat. We have all notebooks rendered by now, actually with their output on our documentation website. So this is relatively new. If there's time, I can also show it in the end. If you want to go the next step, you have to both install NetworKit and Jupyter and clone the repository essentially. So you can see here in the shell like a minimal example to install everything, and this is done with the, let's say, traditional pip way. Of course, we can use our just recently created environment here, our conda environment. So there already everything is installed, and I also checked out the repository beforehand. And so what we can do is, with the simple command you saw earlier, everything is already present here. So I can just type in Jupyter notebook dot, because I'm also actually in our repository in the right folder where the notebooks actually exist. And then a local server is started and you can use the notebooks right away. For example, the user guide here. Yes. So we are currently actually preparing a third way to providing our notebooks. And this is by having NetworKit as, let's say, a public service. So we've installed tools with our notebooks, and all in all, not in a Jupyter notebook, but in a Jupyter Lab, which is the more sophisticated version of that environment. So here's a quick overview of how it will look actually. Nope. Here. Sorry. So you have here the notebooks. All in all, you have like a Python interpreter to play with, and you have also minimal package manager or package installation-like capabilities. So this is let's say an isolated environment where you get some time to play around with everything. And back to the presentation. So the infrastructure behind it is based on a Kubernetes environment, more specifically an OpenShift environment. So the system provides a registration page in the end, where you insert your email address, and the system behind the scenes then create a pre-compiled user instance and informs you once the creation and publication, so once there is a public web link, essentially. And everything like the management of the computing resources and the isolation and stuff like that is handled from the cluster itself. We are actually finalizing the setup somehow and dealing with some sharp edges here and there because of the complexity of the setup. Or if everything goes right, the infrastructure will be available soon for public. So the next thing, if you are a developer and have already tried to write an extension for a NetworKit, you likely already came in contact with Siphon. As we already covered, we use Siphon to create the connection between C++ and Python actually. Until the last major release, this connection module here on the left was created in a monolithic way, which means the connection for all parts of NetworKit are actually in the same file. Siphon, in a way, is similar to translation units in C++. So dealing with all code in one file makes cross-includes easier and also reduces boilerplate code. But yeah, over time, NetworKit has kind of outgrown this approach. So by adding more and more features and more algorithms, it just grew too much. With release 7.1, we cut this monolith and created files for each module. In our new structure, there are different file endings for modules, actually. In addition to the already used PIX file endings, we also needed to introduce PXD files for modules, which actually exports some functions to others. So for example, base and graph exports functionality which is then used by centrality. And we hope that this new structure actually makes it easier for developer to add new classes and even modules to the Siphon interface. We also have updated our dev guide concerning that and also created a video which will be uploaded shortly to our YouTube channel, which goes more into detail how to actually create these classes and provide some tutorials. Just click this link or once we publish the presentations, or go to youtube.com and search for HB or Maxi. So besides our efforts to make development process more accessible, we also added automated tests in order to maintain the same code quality across the project. This includes established techniques known from static code analysis and dynamic code analysis. All of this, what is presented here, is tested in our GitHub repository against CI systems like Travis CI and AppWeaver. But also you can do most of this, or nearly everything of the stuff you can do from the command line, from your notebook or PC. For example, I will not get into detail with all of that, but for example, you can do styling checks via check-code.sh, which is a small script found in our base folder of our repository. Besides simple checks for include guards and indentation, stuff like that, it also scans the code for conformity with our styling guidelines using Clang format. Also, recently, we introduced Clang Tidy and its basic static analyze checks. For example, check against possible performance waste due to unnecessary copies. This project is still ongoing since we have to make sure that a certain option in Clang Tidy fits our needs. And of course, introducing such things also makes changes to our code base necessary. Many of the warnings, however, emitted by Clang Tidy are already treated as errors, and you can check your code against it if you build NetworKit with a special flag here. In addition, if you use modern versions of GCC and Clang, you can also build NetworKit with sanitizers giving you information about possible memory leaks. This can help tremendously if you try to find out reasons for segfaults or undefined behavior. And last but not least, you can check most of our code, both C++ and Python, by either Google unit tests or Jupyter Notebook tests. Here, to make sure that if you develop new code, you should also write tests for them so that they are included here. This and more and how to use all this stuff is also available on our dev guide and our documentation website. Yeah, documentation, it's also the last part. So there are also some updates there. I already mentioned that. We released a new version recently, which adds some nice features. So our approach for the documentation in the past was to use common documentation system for C++ and Python. So we used Sphinx and the Bootstrap theme from that for the Python part and Doxygen for the C++ part. So while we have a lot documented and technically this approach works, this has some shortcomings. So for example, you can't search both documentation bases at once, and also there are some difference in style. We tested completely different systems and see that we find a unified documentation so that we can build that. And we tried systems out like Docusaurus, but in the end, our new version uses more or less the same approach, but adds two Sphinx plugins actually, which are called Breathe and Exhale. It's a bit a shame that they don't have a proper logo because they are really nice. They do a really good job in helping us solving this problem. Breathe is relatively well known. It connects Doxygen and Sphinx somehow, but you have to manually write everything from scratch, which is for a large code base like NetworKit, it's not feasible. And Exhale more or less automates this process. So in all, with small changes to the underlying build system, we could create a unified documentation, let's say.